Good morning everyone. My name is Vikram. Today I am going to explain about construction working principle of three-phase induction motor. Let us see. So first let us understand what is an induction motor, how it works. There are very common motors used in all types of industries. One is three-phase induction motor and one-phase induction motor. It works on the principle of electromagnetic induction. It was explained by a great scientist Michael Faraday. So I think it is this topic is there in 10th class. So Michael Faraday says that changing in magnetic field induced current. Whenever a conductor is placed in a magnetic field, an induced EMF is produced in that conductor. This was said by Michael Faraday. So according to that principle, this three-phase induction motor works. Changing magnetic field induced current. Current can induce a magnetic field. So introduction to this motor. Here you can see the illustration of a three-phase induction motor. The complete illustration of motor. Three-phase induction motor are most commonly used type of AC motors in industrial application. They rely on electromagnetic induction to convert electrical energy into mechanical energy. These motors are robust, reliable, cost-effective for various industrial operations. Let us see the construction overview. Three-phase induction motor mainly consists of two parts, starter and rotor. First of all, let us understand about starter. The main components of three-phase induction motor, yes, starter and rotor. The starter consists of a laminated core three-phase windings that produces a rotating magnetic field. The rotor is typically made up of squirrel cage or wound rotor construction, allowing for the induction of currents and generation of a torque. Rotor basically divided into two types. Means there are two types of rotors: squirrel cage and wound rotor. Mostly we use squirrel cage rotor. And next, now let us understand about starter construction. The starter windings are typically made up of copper or aluminum conductor. These windings are distributed in a slots on the starter core to create a balanced three-phase system. The starter core is usually made of laminated steel to minimize eddy current losses. So I think you got starter construction. Now let us go to rotor construction. Squirrel cage rotor consists of short circuited aluminum or copper brass embedded in the rotor slots. And next one is wound rotor. Uh, Mostly we use squirrel cage rotor, so I'm not explaining about wound rotor. The rotor bars or windings interact with the rotating magnetic field to produce a torque. Yes. So let us understand how it works. To move or rotate any object, we have to apply some force or torque. To rotate a motor, there must be a torque. Otherwise, there is no rotation, right? Yeah. So whenever we supply a three-phase current to a starter, that current will taken by the windings of the starter. Whenever these windings take that three-phase current, it creates a rotating magnetic field with some speed. This speed we call it as synchronous speed. For every positive cycle of alternating current, the poles changes, as we know. So whenever rotor is placed in these change in magnetic field, flux and induced EMF can be produced in it. By that, the rotor starts rotating whenever it is placed in a magnetic field of a starter. The rotor speed is slow compared to starter speed. It creates a slip. Due to this, it starts rotating. The the rotor starts rotating, and through the shaft we can use that rotating field, rotating energy to mechanical energy for industrial purposes. Now let us go to induction process. The rotor speed always slightly lower than a synchronous speed of rotating magnetic field. This speed difference is known as slip. It is essential for inducing currents in the rotor and producing torque. The higher the load on the motors, the greater the slip and the torque output. See here you can see the rotating magnetic field. Operation and control. Three-phase induction motor are self-starting and do not require additional starting mechanism. Speed control of these motors is typically achieved by varying the frequency of applied voltage. Soft starters and variable frequencies drives are commonly used speed control and energy efficiency. Now let us see energy efficiency and applications. Three-phase induction motors are highly efficient and reliable for continuous operation. They are widely used in various industrial applications including pumps, fans, compressors, conveyors, and machine tools. These motors are preferred for their simplicity and ruggedness and ability to operate in harsh environments. Yeah, in many cases, these three-phase inductions are seen nowadays. So, as we came to know, now let us understand maintenance and troubleshooting. Regular maintenance, including lubrication and insulting checks, is essential for optimal performance of induction motors. Common issues with induction motors include overheating, bearing wear, and insulation breakdown. Troubleshooting techniques involve testing the motor windings, checking for mechanical fault, and monitoring operation condition. Conclusion: three-phase induction motor plays a crucial role in industrial processes, providing reliable and efficient mechanical power. Understanding the construction and working principle of these motors is essential for their proper operation and maintenance. Continuous advancement in motors technology aim to improve efficiency, performance, and sustainability in industrial applications. Thank you.